with ecosystem ecology, and then after that I will start with the primary productivity, and I try to relate the sustainable forest management, because after primary productivity I'm going to explain why I choose forest itself, because forest is one of the major contributor to the primary productivity in the whole world. So that's why I choose forest, and then how to actually sustain the natural resources that we have in the forest via sustainable forest management, with some application to be specific in Malaysia. So student in Indonesia, at least you can learn a little bit and also have some information on what happened in Malaysia, specifically in Peninsular Malaysia. And then we have also some case study, and last but not least for Q&A session. Okay, so here actually the starting point of ecosystem. So I think everyone knows that the ecosystem composed by 3 basic components. So these 3 basic components that the student must know is actually producer, consumer, including the decomposer, and then when the producer and the consumer die, they will all contribute to the dead organic matter. And then the dead organic matter later will be decomposed by the decomposer, and then it will the decomposer will return back the inorganic material to the ecosystem. So that is actually the processes that happen in ecosystem. So that's why if you want to mention the basic component that we have producer, consumer, including decomposer. We have inorganic and dead organic matter. And I always said to the student that if you want to mention consumer as one of the component, you still need to mention decomposer, because decomposer also is part of the consumer, even though the function is like to degrade the dead organic matter, but still they are playing a big responsibility in the ecosystem. Okay, so what are the processes happen in ecosystem? Because we always hear like forest ecosystem, marine ecosystem, tundra, RT ecosystem, but basically they are sharing the general main processes in ecosystem. Number 1 is energy flow, and number 2 is chemical cycling. So here you can see the pictorial image of the 2 processes. So the energy flow basically represented by the red color, okay, and the chemical cycling is represented by the blue color. So the energy flow, as we know, that we have the producer, we have multiple level of consumer, and the photosynthesis process will be conducted by the producer, of course, as an autotroph. And then the energy will be received by the primary sources of energy, which is sunlight. And then the sunlight will the sunlight will strike the ecosystem, and the photosynthetic organism will absorb, conduct the photosynthesis, and then they will transform the energy into chemical energy, which is in food. And then when the consumer eat the plant, or the consumer eat another kind of consumer, they will get the energy. That will be the transfer of energy, the energy flow from one trophic level to another trophic level. So that's why you can see that red, I can say red arrow indicating from one point to another one point. But when the primary die, the primary producer die, the consumer die, they all will contribute to the detritus here. So detritus is the dead plant and also dead animal, and later the decomposer will break down the dead material and return back the dead material to the to the ecosystem. So this is represented by the blue color. So this pictorial image basically present to you the 2 major processes happen, and this is also happen not only in forest ecosystem but also in all kind of ecosystem. Okay, so I hope later I will share the slide with both of the institute, ITS and also UiTM, so later you can reflect back the processes and also this with this pictorial image. Yeah. Okay, so not to forget, in ecosystem ecology, we also need to understand the 2 laws of thermodynamics, because for every energy transfer and also for every energy transform, and whatever things that happen between that processes, that can be related with the law of thermodynamics. So we have 2 laws of thermodynamics here. The first one, As you can see from the picture, energy can be transferred or transformed, but neither created nor destroyed, because we know that energy cannot be created. We also cannot destroy, but what we can do is actually to sustain the energy. So we can, like the producer, they will receive the energy from the major sources, and then they can transfer the energy to the consumer, and also they can transform that light energy to the chemical energy in the food. So that is the transfer and transformations of energy. So number two here, as you can see, the cheetah, when the cheetah run, or when the cheetah or any kind of animal, they undergo any physical movement or physical activity. So basically, this is where we can see the transformations of energy from the thing that the consumer eat. For example, cheetah, they get food, they get the energy, and then the chemical energy transform into kinetic energy when they work or when they move themselves. So there is a kinetic energy. So for every energy transfer and transform, it will release heat via respiration. So that heat basically can increase the disorder. Disorder and entropy is actually the particulate matter that we cannot see using our naked eyes, but we know the existence of, for example, water, H2O, carbon dioxide, nitrogen. So that heat release via respiration will increase the disorder. So if let's say you want to understand the the processes in ecosystem, it is actually related, interrelated with the law of thermodynamics, because for every trophic structure, basically they transformation and also transfer of energy happen. And of course, for every transfer and transformation, each of the component will undergo respiration. Okay, so since we have producer, we have consumer, we have that plant, we have also that plant animal, and we have also microorganism. So we cannot blanket all kind of component under same food chain. So that's why in ecosystem we have two types of food chain. The reason why we have these two types of food chain, because we have vast and major component. So the first food chain, this is meant for the grazer, and the second food chain, this is meant for detrital food chain. Okay.
Excuse me, Dr. Faezah, you already accidentally mute, I think. I will.
How long did I
Yeah,
mute?
great. Yes, it's already.
Okay. How long did I mute just now?
No, I think you accidentally touched
Okay.
the mute one.
Okay, so the primary producer here, as you can see in the grazing food chain, we have the primary producer, where the primary producer will transfer the energy to the herbivore and also up to the carnivore. And usually in one food chain, we can have up to 5 organisms. So this is only for example, where I pick three, what we call it, three component in one food chain, just for you to understand the type of food chain. And another one, we have detrital food chain. So for this detrital food chain, this is meant for dead plant and also dead animal. So the dead plant and dead animal, this will be categorized in the detritus, and then it will be decomposed by the decomposer. We have so many kind of decomposer, for example, bacteria, macrofauna, macroflora, and then the decomposer herbivore also later can be eaten by the carnivore. And of course, in ecosystem, these two type of food chain, they are not stand alone. So they are actually, they are also interconnected. So as what you can see here, just now it is like two different food chain, right? But now you can see how they are interconnected. Okay, so from here, you can see this brown solid arrow. This brown solid arrow basically to indicate the transfer of energy. So for example, when the producer die, they will contribute to this detritus component. And then when the herbivore die or when the carnivore die from the grazing food chain, they are all will contribute here. Same goes to the carnivore and the decomposer herbivore. And the carnivore from the grazing food chain also, they can consume decomposed herbivore from from the detrital food chain, and then the carnivore from the detrital food chain also, they can consume herbivore from the grazing food chain. So these two kind of food chain basically interconnected, so they are not acting as a single entity as itself, but they can interconnected because we know each of the organism in the ecosystem, they are related to each other. Okay. Okay, next one. Okay, we come to the, I think this is like almost the second part of the topic where I have ecosystems energy budget. Okay, before I go further on this ecosystems energy budget, I always ask the student, during my class, I always ask the student, why do you think we have this word of ecosystem energy budget? Why must we have this budget thing in the title? Or sometimes when you read book or paper or journal, they will call it as a global energy budget. Why don't just simply ecosystem energy or global energy? Why should that have kind of a budget word there? This is because not all of the photosynthetic organism that conduct the photosynthesis will receive the whole bulk of the sunlight. So they will only receive like a small strike of the sunlight because some of the solar radiation that hit the earth, it will be reflected back by ozone, and some of it will be reflected back by atmosphere, and then some of it will strike the photosynthetic organism. So only this portion available to the plant for the plant to conduct photosynthesis. So that's why the name is actually ecosystem energy budget, or sometimes you will find global energy budget because we need to have like limitation to use the light energy for the plant, and then they want to transfer that small portion of light energy into chemical energy in the form of food. Okay, so that is why we call it as the ecosystem energy budget. Okay, sets the spending limit for the energy budget of the entire ecosystem, because we cannot spend 100% of the sunlight saturation. So it's actually similar with the student. If let's say you were given like maybe 100 ringgit for 1 week, so of course you need to budget yourself as well. Unless you are too rich, then you can use that 100 ringgit per day, right? But I think most of the students, if let's say they receive that 100 ringgit from their parents or from their family, so they will try to budget the limit of the usage. For example, maybe 10 ringgit per day for food, or maybe 20 ringgit per day for food. It depends on you. So even human also has its own budget. What more to the ecosystem, because ecosystem, especially the photosynthetic organism, the producer, they only receive a small fraction. So they are using that small fraction to convert into product. That's why in terms of the definition, actually we have another kind of proper definition, but the light, what can we say under energy budget? Basically, it's a conversions of the light energy to the product energy, and also that product, the product is actually the layman understanding is actually food. So that product will measure the productivity. So for example, if let's say we have more autotroph, we have more phytoplankton, we have more trees, we have more photosynthetic organism, then we can assume that the ecosystem at that area should produce more food or more productivity. So that's why these ecosystems energy budget are very close to the primary productivity, or I can say you must understand productivity in ecosystem topic. Okay, so overall I can say for energy budget, it is where you can measure conversion of light energy to product. So product is actually the chemical energy. Okay, when we talk about productivity, since we have producer and also we have consumer, all right, so that is actually where we need to differentiate between two types of productivity. So the two types of productivity that we have here is primary productivity and also secondary productivity. The first one, primary productivity, of course, it is actually the conversions of light energy to chemical energy that is conducted by autotroph, or in another word, light energy converted to product, because primary productivity, it is meant for the producer or for the autotroph. But of course, we know that the product will be consumed by the consumer, and the consumer also will get something from that food. For example, when you eat something, of course you want to get energy. That is actually your direct understanding. Okay, I think you want, if you want energy, if you want to study more, for example, you feel so lazy or you feel so cold, for example, you want to eat more. You want to eat more because you want to have that energy. So that energy, the thing that you eat, basically uh, not only to increase your metabolic rate, it is also not to be used to increase your body weight. It is also not just to increase your energy, but it can be used to repair the old tissue or damaged tissue. It also can be used to respiration, and maybe some of it will be excreted in the form of feces and urine. So that is the thing that maybe you miss to know about, where the energy or where the food goes into one body, especially for the consumer. So that is where we want to measure the secondary productivity, because secondary productivity is actually the efficiency of the energy. Energy that is efficient for the consumer that will be converted into their biomass. So it is not energy that you eat food that you eat and then that energy you use to run, or that energy that you use to study, but the energy that is available to the consumer biomass to increase your body weight. Okay, so what is secondary productivity? Amount of production of energy available to heterotroph that is efficient for production of young and also growth of new tissue and also biomass. In another word, let's say the analogy for human, if you eat something and then if you burn that energy, you burn it to any kind of physical activity. Let's say you are very active during the day, and then you just sleep during the night. So you use like maybe more of energy, and then the remaining of the energy will be converted into fat. So that's why you don't gain your weight, because you burn that energy. But if let's say another person eat same amount, but she or he did nothing, just stay still, maybe they do not do any physical activity or exercise, so the whole energy will be like maybe most of the energy will be converted into fat. So that fat is actually the thing that will increase the body weight. So in the secondary productivity understanding, it is actually the efficient energy that will go to the consumer biomass. Okay. So again, in primary productivity, we still need to consider the, what we call it, the energy loss, because as I said earlier, it is related with the what we call it, the law of thermodynamic. Okay, so the second law of thermodynamic, where we have when the energy, for every energy transfer and transform, there will be energy loss via respiration, and it will increase the disorder, right? So of course, if we want to measure the productivity, we need to also consider that respiration rate, because that would be the energy loss. So you cannot conclude that as a productivity of the ecosystem. So that's why we have that net primary productivity. As simple as to measure the net primary productivity, you can use the GPP and minus with the respiration. This is actually the direct, what we call it, the direct definition of what is GPP, energy fixed via photosynthesis per unit time. Why we have this per unit time? Because most of the primary productivity rate is measured over the year. So that's why the time rate is exists when we want to measure the net primary productivity. While for net primary productivity, it is actually the same, almost the same definition like GPP, except you need to minus energy carbon via energy carbon loss via respiration per unit time. And if let's say you wonder why I have this like colored font, this is actually meant for my student, because I love to use like different colors so that they can see the which one is important, which one is the difference. So that's why I use red color to stress out reduction of the energy loss via respiration that we need to consider when we want to measure the NPP or net primary productivity. Okay, this is for secondary productivity, as I said just now, yeah, because we have two, primary productivity and secondary productivity. Okay, so for secondary productivity, this is what happened when the consumer eats something. For example, they get food from the plant, and then let's say or maybe the predator, yeah, the predator, they get food from the herbivore. So when they eat something, of course, we know that they need that energy to hunt, to run away from the predator, or maybe they want to to hunt for their own prey, for example. Okay, so now let's go. We see what are the purpose of energy consumed by the consumer. The first one, energy, of course, it is in the form of plant consumed, will be passed to the body in the form of waste product because not all of the energy is usable. So some of the energy that consumed by the consumer will be excreted out in the form of feces and urine. So of course, this energy is not efficient. And then some of the energy will be lost via respiration because we know every energy transfer and transform, there will be energy loss via respiration. That's why we have that net primary productivity. And number three, the remaining of the energy from number one and number two, this is meant for maintenance. Okay, so what is maintenance? Maintenance, for example, as I said just now, for the predator, when the predator want to hunting for their prey, or maybe for the prey if they want to run away from the predator, and maybe for some animal, if they don't want to hunt, or they won't be, or maybe during their usual day, they will just perform any physical activity that they want. So those are the maintenance, yeah. So the remaining of the energy after usage at number 1, 2, and 3 here, those are the energy that is efficient for the consumer to be converted into their biomass. So that's why if let's say you have like as simple as a house pet, for example, and then you feed your house pet. If let's say your house pet are very active during the day, for example, or your house pet is very active, so we can monitor maybe the body weight of the house pet compared to another one that is very lazy or inactive during the day. So we can see the increment of the biomass or the increment of the body weight. That is actually the efficiency of energy, where we call it as a secondary productivity. And also not to forget, even it is secondary productivity, but still there is also a net secondary productivity. It is actually similar with primary production because I don't provide a slide for the net secondary productivity, but if you have any chances to go through any textbook, or maybe you can just browse net secondary productivity, there will be also another calculation for that. Okay, so I think, am I too fast or are you all okay? And I can see that we have 104 participants here. I hope the students
More than 100.
still can follow, yeah? Okay. So next is the limitation. The limitation are here because we know ecosystem is not static. Ecosystem is dynamic. So the ecosystem can change due to many factors. And those factors, of course, some factor is suitable to be discussed in aquatic, and some factors is very suitable to be discussed in terrestrial ecosystem. Okay, so these two are the famous discussion for the limitation in primary productivity, one in aquatic and another one in terrestrial ecosystem. Okay, so the reason why most of the ecologists, they prefer to explain more on aquatic and terrestrial ecosystem, this is because as you can see, these two, aquatic and also terrestrial ecosystem, contribute to the most primary productivity in the world. So the top three contributor here, estuaries, swamps, and marshes, tropical rainforests, okay, those three are the most top three contributor to the net primary productivity. So as you can see, the standard unit also, they are using time factor to measure the primary productivity. Yeah? As you can, if you can relate with the primary productivity equation just now. Okay, so for tropical rainforest, for the terrestrial ecosystem, terrestrial ecosystem, we have here like tropical rainforest, we have temperate forest, and then we have also savanna, taiga ecosystem, agricultural land. So there are a lot. And then if you can compare with the least three contributor, down here we have ocean and also desert ecosystem. So ocean and desert ecosystem contribute to the least amount of primary productivity in the whole world. So that is why most of the ecologists, they prefer to study those two major ecosystem, aquatic and also terrestrial, and what are those factors affecting. So I will give you like a very simple simple example. Okay, alright. Ibu Iska or Ibu Indah, how can I hide this thing here?
Excuse me.
How to hide those bar on top of the slide? Or is this normal for the presenter?
Oh, there's a recording and live on YouTube. That's
Yeah. Can I hide
okay.
this
Maybe
one?
yeah. Maybe it's normal for the view of this Zoom meeting.
It's okay, but sometimes it's a little bit annoying.
Okay.
Actually, I just want to hide, but I don't know where's the button to hide that bar, information bar there. As long as the student can hear and also understand. Okay, so okay, I just proceed.
Yeah, I can see your bar right now.
Is it? You can see my bar, right? So
Yes.
and also people can see how many people enter the waiting room.
Yeah.
Yes.
How to hide that one?
Okay.
This one. Oh, this view of this one.
View of the participant, do you mean?
View of participants.
In the waiting room?
It's okay.
It's okay?
It's okay.
Pardon me.
All right. So primary, okay, this is the first one. Okay, I will give you some example. This is what happened in aquatic ecosystem. So we have here Sargasso Sea. This is actually one of the picture of Sargasso Sea. And I believe that the Sargasso Sea is very famous. If you just Google about Sargasso Sea, you know that the open ocean covered by the sargassum seaweed. And then the sargassum seaweed, it is actually floating throughout the ocean. But even though they have many sargassum seaweed, but for this aquatic ecosystem, for this example of the Sargasso Sea, they are having a low number of phytoplankton. And phytoplankton, as we know, is the autotroph that will conduct the photosynthesis, but they are lacking with that. So maybe
Excuse me, Dr. Faezah, your voice is mute. Maybe you click the mute one.
Button.
Okay.
because I can see that the host mute you. I thought you mute me.
No, I didn't mute.
I think yes, sorry. I think we have
mute me, I think.
no.
Okay. So Sargasso Sea. Okay. So they are lacking with phytoplankton. All right. So maybe some of you will think, okay, why are nitrogen and phosphorus is one of the factor that limit the primary productivity in aquatic ecosystem. Why not temperature, or why not maybe precipitation? Why not climatic condition? The reason is because if we make a very simple interpretation and understanding, NPK, as you can see there, nitrogen, phosphorus, and also potassium are the most important macronutrient to the plant to grow. So that's why it is important for the plant, not only in terrestrial but also in aquatic, to have those component. Okay, but let's say in terrestrial, we have like a very limited issue to this NPK, because we can simply, if let's say we know the plantation, or maybe we don't have issue in forest because it is naturally embed in the soil. But if let's say we know that, for example, the plant are lacking with nitrogen, phosphorus and potassium, we can actually brought that plant, for example, to the greenhouse, and then we can control the concentration of NPK in terrestrial ecosystem. So there is no issue of that nitrogen, phosphorus and also potassium in terrestrial, but not in ocean, because it's very far away, and also it's very difficult for us to control the NPK value in the ecosystem, aquatic ecosystem. So that's why the NPK issue is one of the major issue that can limit the aquatic ecosystem primary productivity. So what I'm going to tell you here, like in Sargasso Sea, since they are lacking of phytoplankton, we are not trying to add the nitrogen, but the researcher, they did one experiment where they add on iron content, and that iron basically can increase the cyanobacteria growth, because we know that the cyanobacteria is very important to develop a pocket of nitrogen, and then the pocket of nitrogen can be used by the phytoplankton. So eventually the phytoplankton will blooming, will proliferate, and also the photosynthetic rate can happen from there. So that is actually why nitrogen, phosphorus, and also potassium is very important, especially in aquatic ecosystem, not in terrestrial ecosystem. Yeah, but still NPK is important for all kind of plant. And then when we look at terrestrial ecosystem, okay, for terrestrial ecosystem, usually the ecologists will study the factors, for example, climatic condition, which are temperature and also rainfall, precipitation, because temperature and rainfall, these are the two things that can influence the evapotranspiration rate, because they said that the evapotranspiration rate basically can indicate the productivity of one ecosystem, especially in terrestrial ecosystem. So if you can look at again to this what we call it figure, okay, you can see these three group. Maybe you cannot see here, you can imagine that three group. This is the first group. Estuaries, swamp and marshes, and tropical rainforest. And basically our focus is the tropical rainforest. So the tropical rainforest, they are having like in Malaysia, Indonesia, Singapore, all Southeast Asia, we are having almost similar climatic condition where we are receiving almost equal day and also night length. Okay, so that is actually where we can have like an ample light saturation, and also we receive optimum amount of precipitation, where that sunlight and also the precipitation can boost the evapotranspiration rate in tropical forests. Okay, but if you compare with extreme ecosystem like open ocean and also desert, they are basically receiving very high light intensity or maybe very low light intensity. So the extreme condition also can influence the evapotranspiration rate. So we also have like moderate country or moderate ecosystem, okay, that receive moderate amount of precipitation and temperature, that also can be translated into moderate amount of evapotranspiration rate. So that's why here this definition, this explanation, tropical rainforest with warm wet condition are the most productive of all terrestrial ecosystem. If you compare with the low productivity ecosystem like desert and also Arctic tundra, because they are having like a little bit extreme, they are receiving like a little bit extreme different climatic condition. And then we have also moderate ecosystem, ecosystem that are receiving moderate climate, for example, temperate forest and also grassland ecosystem that are having intermediate productivity. So basically in terrestrial ecosystem, the climatic condition will be the crucial factor that will influence the primary productivity, because later that climatic condition will influence the evapotranspiration rate. So I also provide here actually one paper, but I'm not sure if you can look at very well the name of the author. It is actually by Stephen and I also cannot read from here to small. Moshong, I think Moshong Zhao. Okay, so they both conduct a study on continuity, how to measure the productivity in various ecosystem habitat, and also as you can see here, this is the relationship of primary productivity and evapotranspiration rate. And according to them, generally high gross primary productivity correspond with high evapotranspiration rate. Later when I share this slide with you, maybe you can look for this kind of paper, and maybe you can have like your deeper understanding later on what is the relationship between the evapotranspiration rate, between the climatic condition, evapotranspiration rate, and how it can reflect the primary productivity in terrestrial ecosystem. Okay, so okay, we are already 45 minutes, right? I I hope the students are all okay. Can
They
I
are
I
okay.
think they okay.
okay, so now we are moving forward to the sustainable forest management. But before I switch to SFM or sustainable forest management, I just wanted to let you know why the continuity, why we need to have that sustainable forest management, or why we need to sustain all the natural resources that we have in what we call it in our place, in our country. For example, in Malaysia or in Indonesia. Why is it important to have that sustainable forest ecosystem or sustainable forest management? Okay, so the first thing that you need to understand, or if maybe you forgot, you can just refer back to that figure. The top contributor to the primary productivity is tropical forest, and also aquatic ecosystem. But I try to fit into the topic where I choose the tropical forest, because tropical forest is one of the most productive ecosystem, right? But we know that over the year, they are also demand from the human population to actually, maybe they want to cut down the trees, cut down maybe not all kind of the trees, but some of the trees, so they want to have some space for development, for example. So the deforestation, or maybe the fragmentation, or any kind of activity that can actually reduce what we call it, the forest pristine condition. Okay, so that can increase, or that can actually release the carbon dioxide to the atmosphere, because we know that each of the plant, let's say you want to for example, you want to not measure, I can say estimating lah. If let's say you want to estimate the plant biomass, for example, usually the people will, I hope the student in UiTM, you understand that, because we still not reaching this topic yet. So maybe they are still a bit blur. What is biomass, tree biomass? Tree biomass is like, in a simple way to say, it is a weight lah, a weight of tree, berat pokok. Berat pokok ke? I'm not sure am I using the right term. This is for layman. So if you want to measure the biomass of the tree, the carbon, organic matter in tree, so usually we will use the weight of branch, weight of trees, weight of leaf, and also weight of stem. But in one tree itself, it is not only the carbon, it is not only the biomass, but we do have the, what we call it as a carbon content. So 50% of the biomass value of the tree, any kind of tree, they basically keep the carbon. So that carbon basically will be kept in the tree in order to cooling the environment system outside. So if let's say deforestation happen day by day, or maybe not by day, yearly, over the year, so of course when you cut the trees, the CO2 also will be released in the ecosystem, so it will increase the temperature, and of course the climatic change will happen, right, over the years. So that's why the concern is actually to study more on the forest and how to actually sustain how to sustain the forest ecosystem natural resources, but at the same time we can actually fit what the population and what the human wants. So that's why I try to embed the sustainable forest management in ecosystem topic. So basically, how the sustainable forest management can help to reduce carbon dioxide by having sustainable cutting cycle maybe. So I provide you with these two, I can say two pictorial image. Okay, so we have here harvested forest and we have here non-harvested forest. How if the forest undergo sustainable forest management, and how if the forests they do not implement any sustainable forest management, they just cut whatever that they want, for example. So your journey starts here. Okay, but I will just explain. Yeah. So here, this is the fascinating fact where 50% of trees dry weight is carbon, as I said just now. And usually, this is what we can see in our kind of forests. I think in Indonesia also you have your own intact forest ecosystem. In Malaysia, we have like Taman Negara, for example. So once you enter the forest, you will find like lots of trees. So those trees basically keep all the CO2. So can you imagine that when you go to the forest, you have like the juvenile trees, you have like middle age of trees, you have like old trees as well. So they all keep the CO2. Okay. But then when we do the sustainable forest management, we cut the trees within the allowable cutting limit, for example, for every maybe 30 to 40 years, for example. So that cutting trees basically, we know that when we cut the trees, the CO2 will be released in the ecosystem. But at the same time, the forest will be have some space for, especially for the juvenile. When you cut the trees, there will be some space. So that space, or when there is no like canopy, because when you cut the tree, usually you will cut like old trees like 40 years old, or maybe 30 to 45 years old, for example. So that 30 to 45 years old trees, they have like a very thick canopy. So when you cut them, it will allow some space for the light penetration to reach to the bottom part of the tree. So this will actually boost the growth of the young trees. So that young trees, when they grow, throughout their growing process, basically they also will keep the CO2 level. So young trees, like young people, they can absorb more. So compared to old trees, old people like anybody, they also can absorb, but the efficiency of the CO2 absorption not as good or as efficient as a young tree. So that's why it is good to have sustainable forest management if you want to keep the natural resources sustained, but at the same time, we still can allow like a moderate cutting limit. Yeah. Okay, if let's say you compare with the non-harvested forests like here, okay, imagine that you do not harvest anything, you do not harvest your forest. Okay, and then what you can see here, all the old trees. So the old trees will keep all the CO2, but at the same time, they are also not so compatible to absorb the CO2 level, because we don't allow the growth of the young trees. And if let's say you want to wait for the old trees to die, they can die, but the tree die because of multiple purpose like lightning, forest fire, damaged by the wind, disease, or maybe because the old age. So we have to wait for so long time for the old trees to die, and then later we wait for the growth of the young trees. So that is not so efficient actually. So that's why the sustainable forest management is implemented, I think, like throughout the nation, because they know we cannot reduce the deforestation, but at the same time, we need to also sustain the natural resources that we have. Okay, so that is the reason why we at this stage now, where we have the sustainable forestry, and I believe that all the students in ITS, you have your own information and also knowledge on the practice of sustainable forestry management in Indonesia. But I just want to share with you guys what we have in Malaysia, specifically in Peninsula Malaysia, and also how it happens. Yeah. But I think no harm for the student to understand, also to look at different view of SFM. Okay, so before we go deeper, I think the student need to understand, even me myself also, I'm still keep learning what is sustainable forestry, because I know it's a little bit impossible for us to understand, or maybe it is impossible for us to know what is sustainable forestry. Sustainable forest is like almost impossible because logging itself, how can logging ever be sustainable when the definition requires the trees to be cut down, right? So yes, it's very difficult to achieve that sustainable forestry, but our effort, every single effort is count, right? So the most important thing is the implementation. So the complete answer, the complete answer to that I can say, if you had to reduce to one word, what is a sustainable forestry? It would be the balance. So how to balance the needs of the environment, wildlife, and also forest community, but at the same time, people can support decent income from the, what we call it, decent income from the forest product. And also there are many practical steps that one community or one business party they can take to protect the health and longevity of the forest, because I believe different country like Malaysia, Indonesia, because we both having like high biodiversity in our forests and also in marine ecosystem. So there are many practical steps, and also there are many ways actually that we can suit with our own kind of habitat structure and also with our kind of needs. Yeah. So these are the criteria for sustainable forestry. I don't provide you with the notes, just like a picture, a cycle picture of the criteria for sustainable forestry. So what we have here, the first one is actually, the first one is to achieve conservations of biological diversity. I believe this is actually, we are sharing similar target and also similar vision, not only in Malaysia, but I believe Indonesia also, whatever that you all do, we try to sustain whatever that we have. But at the same time, we try to we try to fit the need of everyone. Yeah. And number two, to maintain the productive capacity of forest ecosystem, because we have production forests and we have also protection forests. So that's why the production forest is needed. At the same time, also we need to have that kind of protection forest. Number three, to maintain the forest ecosystem health and vitality, to conserve and maintain soil fertility, because we know that soil contain macro and micronutrient that will influence the species composition at one area. So that's why by having high biodiversity, specifically in species composition, it can help to maintain the soil fertility and eventually the water reservoir in that forest. Maintenance of forest contribution to the global carbon cycle, because we know the major concern is actually to reduce carbon emission. Yeah, even though there are many biogeochemical cycle, yeah, but concern is carbon cycle, to maintain an enhancement of long-term multiple socio-economic benefit, and last but not least, sustainable forestry at any kind of country basically will be provided with a legal, institutional, and also economic framework. Like in Malaysia, I'm not sure all those policy legislation that we have in Indonesia. I believe Ibu Indah, Ibu Eska, you are all expert on that, yeah. But I would like to share what we have in Malaysia. For example, we have National Policy on Biological Diversity. This is the revised version 2016 until 2025. And we also have National Biodiversity Policy. For legislation, I just name some that I can remember. Access to Biological Resources and Benefit Sharing Act for 2017. And I'm not sure what is the English name, but we still use like the legislation they are using like bahasa Melayu, peraturan-peraturan akses kepada sumber biologi dan perkongsian faedah 2020. That is the latest one. So we also have like Conservation Act for Wildlife and also National Park. I believe all countries basically they have those legal institution and also economical framework to support whatever activity that is conducted to that forest. Okay, so this is the history of forest management, because I know every single country, they have their own history and sweet story, sweet story, long story, what kind of management that they adapt. And as for now, we are adapting selective management system. So here we have Malayan uniform system. This is actually the initial forest management that we have. And here it is formulated in 1949. And what is actually Malay uniform system? It will involve felling all commercial species. This is the initial, all commercial species that is more than 45 centimeter, and the cutting cycle is within 50 to 60 years old. So I can say very old trees, 45 centimeter, and also the cutting cycle is a little bit longer, which is 50 to 60 years. Each cutting cycle is then followed by silvicultural operation because they want to monitor the growth for the trees at regeneration level. But the silvicultural operation, they tend to eliminate the non-commercial species of more than 15 cm. So can you imagine that from intact forests, when they cut down the commercial species that is very old, but then later they also eliminate the non-commercial one, that is more than 15 centimeter can be considered a big trees, yeah. So the reason is because they want to reduce competition, because they want to allow the growing of juvenile commercial species. So this is Malay uniform system. So as I said just now, the Malayan uniform system is to convert from intact forests, which multi-species and multi-age, to even age, almost equal age of 3 species, but a commercial species only. And this is actually suitable to the lowland forest, but not to the hill dipterocarp forest. And if let's say you can imagine the lowland, it is located at the lower elevation compared to the hill dipterocarp forest. So of course you can understand why those Malay uniform system is not suitable to the hill dipterocarp forest because of the elevation, because of the species composition that we have in hill dipterocarp forest. But later I will show you the slide of some reasoning why the application of Malaya United System is not suitable in hill forest. Yeah. So what we have here, the application here, I think this is very straightforward. You can just go through number 1 until number 8. Why it is failed in hill dipterocarp forest? But before I explain a little bit on this, maybe for some of you, maybe student in ITS, you are very expert on the locality of the forest, but I just want to show to the others that maybe you forgot where actually the locality of lowland and also the hill dipterocarp. So as I said just now, Malayan uniform system is suitable at the lowland area, which is located at very low elevation. Not so low elevation, because if you really go to the forest, that 300 meter is very high and it's quite tough if you want to reach at the top of the lowland dipterocarp forest. But if you go further here, you will reach this hill dipterocarp forest. This is too steep and also too high as compared to this one. Okay, and in some forests, for example, in Taman Negara Pahang in Peninsula Malaysia, if we have chances to go, if you start the journey from the hanging bridge of the Taman Negara, you will find that lowland first, but when you go deeper until, I'm not sure what's the name of the cave, you will find the hill dipterocarp, and it's a little bit tiring actually to reach up to that hill dipterocarp forest. So that is the reason actually why Malay uniform system is not really suitable to the hill dipterocarp, because it is almost impossible to maintain what we call it commercial species at this area is very high. Okay, sorry. So this is the reason why Malay uniform system is not suitable. It's not like a total failure, but I can say it is not really suitable to the hill forest. The first one is because difficult terrain. As you can see from the picture just now, it's very high, up to 750 meter. Even there are also upper hill dipterocarp forest that can go up to 1000 and also 200 meter. Okay. And number 2, this is because this is not this uneven stocking. So uneven stocking because sorry. Okay, so uneven stocking because stocking, it means the number of dipterocarp trees. So stocking has been far more irregular in hill dipterocarp forest than in lowland forest. So there are many studies, for example, Manukaran, Swan, Burgess, long time ago, where they reported poor representation of dipterocarp trees, and also the stocking of hill dipterocarp usually can be found only at lower slope and also valley bottom because it is influenced by the topography of that area. So that's why the Malaya uniform system is not suitable at hill dipterocarp forest. And another one reason is because when the um, felling system happen in hill dipterocarp forest, basically there will be high incidence of Eugissona tree stain. This is actually, in Malaysia we call it, the local name is pokok nipah or pokok bertam. This is actually the trees lah, and this is actually the usage. And this is what we call as a secondary species, common species at secondary forest. And this species usually has many uses. For example, house partition, for screening, basket, and also to making roof. So that is the reason why they don't really favor to do this Malaya uniform system in hill dipterocarp forest because of this high incidence of bertam or nipah. Because actually, as I said just now, usually when we cut down the trees, we want to allow the big trees, I mean like the dipterocarp or the non-dipterocarp trees to grow, not this kind of bertam. But still, bertam also has its own value, yeah, but not too much like this, like in hill dipterocarp forest. Okay, so this is just some eye candy picture to show you the typical hill forest in Peninsula Malaysia. Typical hill forest in Peninsula Malaysia, where we have a gigantic Shorea curtisi. I think in Indonesia you name it as a meranti merah, is it?
Meranti merah, is that
Meranti
correct?
merah. So it can be large as 70 meter if I'm not mistaken. And also this species is common at ridges in hill dipterocarp forest, not only in Peninsula Malaysia but also in Sumatra, Indonesia. Okay, so next is selective management system. So selective management system is actually, oh, it's already 1 hour. Oh my God. I think you can just stop me if I exceed the time, yeah?
Yes, but it's okay. It's
Okay.
still
So this one, selective management system, is actually the alternative way because the forester, they thought that Malaya uniform system is not really suitable to the hill dipterocarp forest, so they try to have another system. They call it as a selective management system. So under this selective management system, the large trees are felled for every 25 to 30 years. So it is a little bit shorter cutting cycle as compared to the Malaya uniform system, and also it can be divided actually into three stages: pre-harvest, harvest, and also post-harvesting. So basically, what happened during the pre-harvest? During the pre-harvest, usually the forest manager, they will get as many information as they can to ensure that all the criteria of the forest that they want to acting upon, they want to cut down the trees, fulfill the criteria needed by the concessionaire. And then they also will do like pre-felling inventory. And as we know that pre-felling inventory is not an easy job, yeah, because it is like walk in the park. Because usually the forest manager and also their crew, they will camp in the forest for like 10 to 14 days like that. And then they will bring the stocking, what we call it, the stocking data. So when the logging concession is issued, then the forest manager must have already data on the stocking of each of the forest component. And then the tree also must be properly marked. It is like when we want, it is like the similar method when you want to sampling, because we need to mark the trees, but in SMS, they mark trees, especially the mother tree that they don't want to they don't want to cut because they want to remain that mother trees. Okay, so they also need to ensure that the concessionaire follow like some rules. For example, directional felling, because we know that directional felling can reduce minimum damage to the residual, to the other residual tree species, yeah. And also before the construction, of course they will develop like a temporary, what we call it, temporary log landing, road, skid trail. So they must make sure that everything is in tip-top condition before the felling process happen. Okay, and during post-harvest, forest manager also must make sure that the enrichment planting is carried out, especially at that area where the skid trail, temporary longyard, and also the campsite happen. This is actually to restore the residual stock for future harvest. Yeah. So this is the pictorial image. I think this one is more practical for the student to look if you cannot go by the word, so you can go to this particular figure so that you can see what happened next until the regenerated forest happen after the felling process activity. Okay, so I have also some eye candy picture for you guys to see the logging practices that happen in the Terrestrial forest, peat swamp forest, and mangrove. But to be frank, I'm not in a in a good position actually to tell you about mangrove and peat swamp forest, because my study area usually is deep Terrestrial forest. But I can provide you the picture, and also this is picture of the felling depression. Okay. So this is logging practices in the Terrestrial forest, and as I said just now, the logging road built within the concession area. This is actually to ease the process of transportation of the log tree, and also for the concessionaire, and also for the forest manager to go in and out from the forest during the harvesting process. Yeah. And we also have here typical temporary log landing site in the forest. And as I said, in selective management system, usually after the harvesting process, the forest manager must make sure that the route, the area for the logging road development, and also the typical temporary log landing site, this will be covered again by the regeneration tree or regeneration forest. Okay, this is typical felling and extraction damage during the harvesting process. And this is the forest recovery after 5 years of logging. But as you can see, they are lacking of big trees because it is only 5 years. And we know that it takes more than, I think more than 5 years or more than 10 years actually to rebuild the forest ecosystem as its original condition after the harvesting system. But we can see that the places are exposed to the sunlight, so this area can allow the growth of the young trees, yeah, that can absorb more carbon dioxide. This is some pictures on logging practices in peat swamp forest. I can only provide you with the pictures because I'm not into that peat swamp forest study, but this is also happened. This is to show you that the sustainable forest management happen not only to tropical forest, which is the tropical forest or dry forest, but also to the peat swamp forest. And also peat swamp forest also has its own logging road, and also this is logging in mangrove. Okay. Even it is a mangrove ecosystem, but they are also undergo logging ecosystem and also a logging activity, and they are implementing the selective management system. Right. And this is recovery process after harvesting in mangrove. There are lots of recovery process, and like in Malaysia, we have one pilot study in Sungai Haji Dorani, Selangor, where we can see the regeneration of mangrove. So if let's say any student here from somewhere nearby Sungai Haji Dorani, so maybe you can experience, or maybe you can just witness the regeneration process that happened in mangrove area in Sungai Haji Dorani. Okay, So next, how does Malaysia balance conservation, forest and its conversion? I think this one is not only in Malaysia, I think all country, especially in Southeast Asia where we have like high biodiversity, it is very important to know how this Malaysia balance between conservation and also conversion, because we know that we cannot stop defragmentation, we cannot stop forest conversion, we cannot stop forest degradation. So what we can do? So basically Malaysia has protected forests that have been legally gazetted by law, and these protected areas cover marine and also terrestrial. So almost half of the total land area and I think 14.5 million hectare. This is actually permanent reserve forest. And out of this permanent reserve forest, it has been divided into protection and production forests. So as you can see, there are some division allocated for production forest, about 80% from 14.5 million hectare, and the rest is for the protection forest. And this protection forest is not just like simple protected forest like what usually we experience when we bring the student to the fieldwork, but it is also including virgin jungle, high conservation area, taman negara, for example. So in addition to that, the protected area also has been further extended by gazetting many national and also state park, like what we have in Malaysia, Taman Negara National, Taman Negara. We also have wildlife reserve, bird and game sanctuary, and many more. Yeah? Okay, so here are the list actually for the some of the protected area, including the size, but some of the area is not provided with the size, as you can see here, and also date of establishment, and they are all very old actually. Yeah? And this is some reserve gazette under the National Land Code at different state of Peninsular Malaysia. And this is the size of the reserve. Okay, so we have here Pulai, Deer, Zoo Melaka. Zoo is like Zoo Melaka, where we have all the various fauna species. Endau Rompin Wildlife, Fraser's Hill, Tasik Bera Ramsar, Tasik Chini, and we understand that what we call it, the International Ramsar Convention on Wetland. That is one of the testimony to the fact that Malaysia also has its own protected area at international standard. Yeah? Peninsular Malaysia State Enactment on Habitat Conservation. This is what we have in various states in Peninsular Malaysia as well. This is what I said just now. Taman Negara National Park in Pahang, Taman Negara National Park in Kelantan, Terengganu, Johor, and we have Belum State Park in Perak and also State Park Corporation Enactment. And if you wonder why this Taman Negara is distributed at several states, because it is actually one continuous, it is one continuous area, but they have like different institution or different state department that control the control the activity and also control that particular national park. This is just to show you the protection forest, what we call it, contribution, and also the production forest. So basically the production forest will give or will provide any product that is suitable or that is needed to the community, while protection forest is actually to balance it back. So that's why I provide you with like overview on how Malaysia basically balance. And we cannot say that balance is like 50-50. Balance, it means that we still have all the process that that can provide the needs of the human, but at the same time we still have something that we can keep for the future generation under protection forest. Okay, so this is some of the environmental impacts of forestry. For example, biodiversity loss. Okay, so the biodiversity loss basically contributed by unsustainable forest operation. That's why it is important to have what we call it sustainable forest management in many kind of countries, especially like Malaysia and Indonesia, where we have high biodiversity species. Yeah, and illegal hunting, increased hunting continues also to be a major threat to forest biodiversity in many countries. And basically the depletion of this wildlife, it linked to the food security, because we know that um, for some forest dependent people, they really need this wildlife as their sources of protein and also income. So illegal hunting is it is actually one of the way, not one the way, one of the what we call it impact to the forestry. Okay, illegal settlement. Okay, another possible side effect of the forestry operation because and furthermore, if let's say this illegal settlement is located at a very deep forest, sometimes it is hard um, uh, for the for other people to access and also for other people to realize the existence of this illegal settlement, because it is very hard to be detected. Yeah? And illegal settlements are a threat to forest biodiversity following construction of new forests, because sometimes they try to develop something else or something new to that area. Livelihood of forest dweller. So this is actually negative impact on indigenous and also local community, because the local community and also livelihoods of other forest dweller, they are competing with this, they are competing to each other to access the ultimate forest resources. Okay, and last but not least, the ultimate what we call it environmental impact is the climate change, because we know that if we do not have that sustainable forest management, then when the tree being cut down without any specific cutting cycle, or if there is no rules and law stipulated in the legislation, then maybe we might achieve a very bad climatic condition in future. Yeah, because we know that all the trees they are actually helping to keep the carbon dioxide. So forests account about 50% of the total above ground terrestrial organic carbon, and deforestation, forest degradation estimated to cause about 20% of the annual greenhouse gas emissions. So can you see like how big the impact of by not having a sustainable forest management, or by not having like those protected area, if we just want to focus to the need per se. Okay, so yet forestry management has evolved considerably in past decade, demonstrated significant positive impact, even though there are many what we call it environmental impact to the forest, but still we managed to um, provide goods to the what we call it to the human. Yeah, so I would like to share with you guys the good practices, and this is not only in Malaysia. I believe Indonesia also has its own good practices. So I just jump to this first case study. Yeah? So I have here case study, and this is like almost the end of my slide. So a case study that we have here in biodiversity in production forest, because we know production forest, forest that can provide income, resources, and also that can boost economy to the community. So what we have here in Malaysia, this is one of the company, Grand Perfect Sdn Bhd. So this Grand Perfect Sdn Bhd is a consortium local timber companies that has planned 3 types of land use in the project area. So the conservation of this conservation program from this Grand Perfect Sdn Bhd, basically to maintain high biodiversity value, within the planted forest zone. They also want to minimize loss of biodiversity due to development. They want to integrate biodiversity conservation with economic and also social need. So this is one of the case study that we have in Malaysia, where the purpose is actually to diverse more species and also to maintain high biodiversity value, even though it is in the production forest. Okay, number 2, we have this one case study in Peru, the reservoir communal Tamshiachu, Tahuayo in Peruvian Amazon, yeah? And we can see like a big area, 3,235 kilometers square. Okay, so what happened here, this area composed by 14 species, I think more, at least 14 species of primates. So there will be more species, and hunting pressure is limited to local subsistence consumption. So they really actually take care of the wildlife reserve that they have. And also some of the sale, because they limit the hunting pressure, so the outcome from this community reserve, some of the sale like in the form of pelts, food for the animal, yeah, where they put them in the sale to overseas market, yeah. And also decision and resources used for this management are voted upon during community meetings, where basically there are many parties like NGO, workers, and also the local community. They are try together to build like effective communication, and also they try to manage the wildlife reservoir that they have here in Peru. So this is one case study in Peru. And last but not least, here we have case study in, this is throughout the nation. I just give you one example of the green wave for biodiversity. Okay, and actually I provide you like a simple video here. This simple video is to show you what we have in Malaysia. This is in conjunction with the Green Wave for Biodiversity. So Green Wave Biodiversity is actually ongoing global biodiversity program. So this is like SEPA. SEPA tu is communication, education, and public awareness, CEPA. So actually there are many initiatives of communication, education, and public awareness. Green Wave is actually one of the global biodiversity education project. They encourage the young people to take responsibility to protect their forest biodiversity, because one of the core principles under sustainable forest management basically is to reflect diverse range of social value in reference to forest conservation and use. So it is very important to have like a holistic what we call it communication, education, public awareness among the indigenous, local community, business, industry, for them to build trust, understanding, and shared agreement. Because I know this is not one single individual effort. This is like a mutual, what we call it, a holistic effort from everyone. Okay, so what we have in Malaysia, we have campaign ke arah sejuta penanaman pokok. We call it as a 100 million tree planting campaign. This is also part of the Greening Malaysia program. I'm not sure if I have like time here to play the video, but I think later if I share you the slide, you can just click on the YouTube link to watch like maybe only 50 seconds of video of the 100 million tree planting campaign in Malaysia. This is actually one of the Greening Malaysia program. And I believe Indonesia also has its own tree planting campaign, yeah. And through the campaign, basically, we estimate to increase around 20 to 80,000 green part of the ecosystem in preserved forests by 2025. Okay, so I'm not sure if you guys still wide awake with me. So can we play like simple tests? Or you want me just to proceed to end the topic? I have actually here like a simple test to share with you guys, but instead of me sharing, maybe I can hear some response from the student. So how is it?
Yes. Actually, you want a student to have a test about this one, right, Dr. Faezah?
Sorry?
Hello? This is for all of the students who already attend this lecture.
So this is like a very simple quiz, not simple quiz. There is no, just to
The student will be like, wow,
yeah,
there's this.
just to test the knowledge. There is no mark given. Actually, you can just play
Okay.
with the knowledge, because I guess after all the lecture, after all the information given,
Mm-hmm.
at least you can understand. Okay, if is it wrong if deforestation happen? Is it wrong if I use anything, any product from the forest? Just a simple question like that. But it's okay. Maybe the student, maybe you can simply click to the link so that you can go and play with the question anytime that you want. Okay.
Okay,
Okay.
great.
All right. So I think I have come to the last part of my presentation. This is actually my current research, just to show you. And I would like to share, I would like to thank to my postgrad student Harsha Hanani, who had actually doing the cosmetic thing to this slide. Okay. And here is one of the study conducted by my postgraduate student. Community, actually I cannot read because I have that balan. Community study, community study of the relationship of three communities at selected forest reserve in Selangor. And my focus here is actually to the secondary type of forest. So there are three types of forest: Kota Damansara Forest Reserve, Ulu Gombak Forest Reserve, and Bukit Tarik Forest Reserve. They are all locked over forests and also can be categorized under degraded or secondary forest. So this is actually some of the finding here, where we can see the diameter breast height, structure or forest structure for all those three type of forests, where they are all having inverse J relationship. Yeah, inverse J relationship, it indicates that the forest ecosystem dominated by juvenile trees. This is actually the DBH class. Okay. And this is to show you the habitat preferences of these three different forest ecosystem based on the physical chemical properties. So we can see that this is one group, maybe, I'm not sure because I cannot see the legend, but I believe this is one forest, this is another one forest, and this is another one forest. So the actually the group indicating that the species are sharing similar ecological requirement. Okay, so basically I'm doing study on habitat structure, species distribution, and then I relate with the physical chemical properties. And this is another one, edaphic influence of tree species and biomass distribution at Bukit Lagong Forest Reserve. Also similar, almost similar finding with the previous one. And this is the current one where I study on the ecological consequences of climate change to forest growth pattern in Peninsular Malaysia. So I'm still in the process to analyze the finding, because I'm using like 30 years data. This is like a big data from Forest Research Institute Malaysia, and also I try to relate with the temperature from 1979 up to 2012. Yeah. And this is another study, kajian impak kempen pembudayaan norma baharu, and this is actually the publication from the study. This is not related with the forest at all, because this is actually related with the pandemic COVID, because we wanted to know the acceptance of the community to the new norm. Okay. And this is some of my postgraduate student. I still have, actually I have some of the students that already graduated. So this is the remaining one that is still ongoing, and also some of the collaborators. So I hope that for any of the students or maybe any of the lecturers, if you want to have like a collaboration with me, so you can contact me at this email and also at this number. Okay. So I think that's all from me. Thank you. Thank you
It's,
everyone who was here. Was
thank you so much,
still-
here's Dr. Faezah, for such an excellence, and we have a lot of information today that related with the ecosystem, with the can we call it sustainable forest management, and the new information about how Malaysia also maintain sustainable forest management with a lot of ways, and maybe there are other advantages and other conflicts we don't know in there, because in Indonesia we each country have their own rules, I think, and
Yes,
we
correct.
will face the same. I mean, not always a good thing happen when we choose the role. Maybe sometime we will face the negative impact and the other thing. So maybe from the student in here that have any questions to Dr. Faezah, you can ask by English or Bahasa Indonesia. It's okay. I think this is the same thing with the Malaysia, right?
Yes. I can accept both language, yeah, so don't worry.
Yeah, yeah.
And we both actually learning. Even we are the lecturers, but we are also learning. That's why we are doing
Yes,
research, yeah. So
yes,
please do not hesitate to ask anything.
yes. Hello everyone, still with us?
Actually, last time when I
Mhm.
when session with Dr. Indah, I forced my student actually to prepare the question.
Yeah, yeah.
Actually, I forced my student, not force in a bad way. Actually, I asked my student to prepare at least 3 questions because they actually came from 3 groups. So at least we have 3 questions that came up. I think there were only 2 questions, right?
Mhm.
Okay.
Actually, Dr. Faezah, can I have a questions also? Because it is my
No
yeah.
problem.
How about local communities in Malaysia? In Indonesia, sometimes if we do conservation in the forest, we we look that, oh, when we choose the local communities, I mean like adat, you means
Ada.
suku,
Yes.
yeah, yeah, that's
Uh-huh.
mean. This is more effective to do conservation in the forest. That better than we talk about rules, we talk about national laws. We just like looks like in the local communities more better than that. Do you think it is also happen in Malaysia?
I mean, like in Indonesia,
Mm-hmm.
the local community, they don't really take part in the forest contribution, or like how?
I mean the and in my case, I found that in our forest site, that the local communities, that the suku in adat, it's more better to conserve their forests.
Oh,
So
okay.
they didn't need like government laws. The other they don't know about that, but they do to willing from the herd, from
Because
their own
in
laws to
Malaysia,
conserve.
we have the local community. I don't have like a personal experience with local community because my study is more on forest. It's nothing to relate with the local community. But I mingle around with some other researcher that also conduct research related with local community. I found that they actually can cooperate, okay, and they are not actually destroying the forest. They live in Taman Negara, for example. They have their own housing, not like proper house like what we have in town, but still they have like their own settlement. They use that pokok nipah as I said just now to build the settlement, but somehow they are a little bit shy actually to take part. If let's say we want to ask something, we want to have like a simple questionnaire to them. So they can contribute, but we need to give them something. For example, like this is what happened in Malaysia. I'm not sure at other country. They can contribute, but they are a little bit shy. They are a bit reluctant to share unless we try to make friends with them. So that's why
Mm-hmm.
for local community, if you want to make a study with them, we really need to stay at that area for at least like 1 week until we can blend with the community, and then we because we want to build trust for them.
Yes, yes, good. Oh, we have one participant who already raised hand. Bapak Muriano, yes. You can unmute, yes.
Yeah, thank you, Iska. It's very cheerful presentation, Faezah.
Thank
Sorry
you.
if I
I cannot see your face. This is
hope
this
the
lecturer as well in Department of Biology.
Yes, yes,
yes.
correct.
Wait.
Already see.
Yeah.
Yeah.
I'm the student of Iska. So
Oh my god. Oh my god. I'm the student of Bapak Muriano before.
Also, Bapak Moreno is actually the senior lecturer. Super
And Bu
senior
Indah
lecturer
also.
in ITM.
I'm also the previous student from Bu Indah and Pak Muriano.
Oh, okay.
It's very cheerful presentation, and maybe just to enrich the discussion around the student also. In our case, we concern for forests, specifically coastal to the upland, and we still very grateful we have Papua for forest legacy, because Kalimantan is being so destructive. So many cases in fire and also fragmentation.
I see.
So my question is, if you have any idea for the global problem about biodiversity and ecological function. So we have you have explained biomass and also biodiversity. I hope it's like exponentially. So if we have biomass, so we have high biodiversity. And the question is about the climate change, especially enhancing of CO2 from now ambient 400 to 600. How forests, especially maybe broadleaf or conifer forest, you maybe have experience for the research, how increasing CO2 influence for biodiversity and biomass. Maybe you have any kind of case that increasing CO2, it's mean increasing photosynthesis rate. So we can assume that increasing photosynthesis, increasing biomass. Increasing biomass, so increasing biodiversity. So you have any kind of experience for increasing CO2, so we can speculate that we have benefit for increasing CO2 better than to make any kind of that influence for CO2, especially forests. Maybe that's it. Maybe after that we can more discussion if you still confusing my question. Thank you.
Actually, I still like my recent study on climate change. I have just started somewhere on end of last year. So my what we call it, the big data, it is actually taken from one of collaborator. So that data is actually taken via the sustainable forest management. So they have like the cutting, they have that cutting cycle, but there is some loop at like certain year. So I cannot actually predict what happened at that particular year. For example, let's say I want to study from 2017 until 2021, but there are some loop like 5 years or more than 5 years in between. So to answer that question, how actually the CO2 concentration can result or can actually affect the biomass, I think I'm still not in the good position actually to answer, because it is actually a long, what we call it, a long-term study. But I believe that when the CO2, when the carbon dioxide increase, perhaps we can see the results in 20 or 30 years in future. But the study that I have done and also the study that I've conducted basically is like 30 years and there is still some load. Is it okay, Bapak Muriono?
Yeah, no problem. It's okay. Because we have many obstacles for forest. Maybe Iska tell about the community, but we have problem mostly in fire. And the second one is habitat fragmentation. And the last one will be so maybe invasive species. So that's why we want to measure the forest that not the forest with a good proportion. So in the meantime, we have many forest culture like coffee, like maybe tetrocarp like rubber, and also many things that mostly is more homogeneous than biodiversity. So we want to make kind of idea what forest management should be nice to enhance biodiversity and also can contribute to the biomass, especially above ground biomass, because wood economy will be nice to measure.
I think as for now there is like no, what we call it, like no one documentation on the best sustainable forest management that I can say, okay, like what we have in Malaysia, because the ecosystem is still keep changing. So if let's say we see that the current sustainable forest management is the best, so maybe in future, if let's say something happen, more deforestation, then maybe we need to change and revise the implementation that we have done. So I think it's it's something that maybe we need to something to ponder to everyone that conduct research in forest ecosystem. So that's why before I'm doing my climate change study, I also take part with environmental researcher where they actually put like some of the plant that they want to study, and then they try to see the impact of CO2 as what Bapak Mujuna said. But the scale is like only in the phase, free air carbon dioxide enrichment phase experiment, or what we call it in a greenhouse experiment. So I think it's still it's very hard actually to say what is the best sustainable forest management. But it's because the issue is keep happen and keep change from time to time. But of course, we still want the best, right?
Yes. Pak Buryono is okay.
Yeah, enough. Even
Yes.
I have a question about the palm, because we have many issues for Malaysia and Indonesia for palm.
Yes.
But I don't mention it here because it's different topic, I think. Thank you.
Okay.
Okay. Oh, oil palm, yes. Actually, we have Sinta Cahyani. You wanna ask the questions?
Yes. My name is Sinta Dewi. I'm from Department Biology TS. I want to ask how are efforts in Malaysia to harmonize forest conversion with the socio-economic status of local communities? Thank you.
How?
I think it is about the harmonization about forest conservation with the local communities. I mean the same thing with.
To the local, so that local communities, for example, like not necessary to be like local communities like Aborigine people, yeah. So like all the local communities. So as I said just now, like we have the permanent reserve forest. So some of the permanent reserve forest is allocated for the production. So that kind of production forest, perhaps it can be used to provide income and also resources to the social community. So it can increase the social well-being. And at the same time, we do have also the, what we call it, the protection forest. So that protection forest under conservation area, wildlife reservoir, and also the national park, for example. So those are one of the initiatives that we have to try to balance between the need of the society and also to sustain that, to sustain whatever that we have in the forest to the future generation. Okay, what's his name just now?
Is that enough, Mbak Sinta?
Oh, Shinta.
Yes.
Yes, Rizka. Thank you, Dr.
Okay,
Faezah, for
thank
your
you.
answer.
Yes, thank you. I think there are many. We still have 8 minutes, so maybe from the participant, from the student, also have any questions. You can just raise hands. Don't be shy because we didn't harming you anything. You can ask with Indonesian, or maybe you wanna try Malaysia also. Because sometimes we can speak Malaysia because my baby is always watching Ipin Upin every day, so I can.
Oh, okay.
Yes, my kids too.
Winda also face the same thing, right?
Okay.
So sometimes we can hear, okay, I understand it.
Yeah, actually, I can understand native language in Indonesia, but I'm a little bit I'm not confident to respond in the same language.
Yes, that's correct. I just understand also, but I don't know how to respond it in the same language. Anything?
From my student in UiTM?
Okay. Oh yes. I also have a report that we have a lot of students from UiTM also. How can I call Mbak and Mas in Malaysia, Ibu Faezah?
Sorry, my student.
Yes. How can I call it? In my language, we can call Mas, Mbak. How?
Oh, Mas.
Mbak Sinta. How can I call it in Malaysia?
Cik.
Cik.
Cik Nur Alia, for example.
Great.
Cik Nur Ai Natasha. Cik Ifah.
Siska, maybe.
Hello, Doctor.
Come on, guys. Do you wanna have any questions?
Mimi, fine.
I still put my student.
That's okay.
Yes, I heard someone called.
I hear someone, but I don't know who is
Dr.
it.
Faezah, it's me, Hannah, for your A2 class.
Oh.
Okay.
I
want to
yes, I see it.
Okay. I want to ask that humans can, we as a human can create a larger city, but why we can create a larger efficient ecosystem? I mean that, is there any limitation to create a very efficient ecosystem? Thank you.
Not really clear actually how
I also will. Okay, maybe Nurhana can you repeat your questions?
Okay. We can create a large cities, right? I mean, we can create a lot of the buildings, but why we can create a large efficient ecosystem. Is there any limitation for this?
Limitation for?
To create a very efficient ecosystem or to
Limitation to create efficient ecosystem. Is it?
yes.
We can speak in Malaysia, so it's okay.
Nurhana is from ITS or from ITS?
Nurhana is from
I think from
UiTM.
ITM, right? Because I have 80 plus students, so I can remember every single thing.
Excuse me, Nurhana. Are you still there?
Maybe Nurhana, maybe you can type a question at the chat soon. But I just can capture limitation of
Excuse me, dear Nurhana, you can text your question in the chat box also, because I think we have I don't know, I am really didn't understand about the limitation of efficient ecosystem.
limitation on what?
Yes, limitation of what? Okay,
That
maybe
limitation of ecosystem efficiency, is it limitation of ecosystem efficiency?
yeah, I think we need to wait. I think
Doctor,
we
Hannah is from UiTM, and then she
Ah,
asked about
ecosystem
yes.
if humans
efficiency.
can, Dr. Faezah,
Okay.
Hannah asked just now regarding about the human can create large cities, but why can't we do create an efficient ecosystem? Like how what the limitation for the humans to create a efficient ecosystem? Because as we know that certain place we conserve to sustain the ecosystem, but also we have an issue regarding something like the current issue, Tasik Chini issue in Malaysia right now. So why can't we create another like large efficient ecosystem? That's what I understand from the Hannah questions.
And okay, so who's talking just now? Is this not Hannah, I think? But okay,
Yes. No,
Saya.
Nabila,
Yes,
yeah.
saya.
Okay, ecosystem efficiency. I think the limitation. I think everyone wants to have like a large reservoir or large ecosystem that is untouched, or maybe that like the students or other researcher they can go to visit and also to study anything and do research at that area, for example, the Tasik Chini. But it is very difficult actually to have like a similar thought like that. There is no actually limitation. If you're talking about limitation, maybe we can say in terms of the space, maybe if we wanted to have like an artificial, not artificial, like a man-made ecosystem, and that man-made ecosystem is efficient to everyone. So there are maybe some other things that the developer or the state that need to consider, like the space and everything. We can develop that, but to sustain is another story. So we can have that, whatever that you want. For example, you want to have like a big ecosystem, for example we have in Putrajaya, we have like wetland in Putrajaya. That is also can be considered as man-made ecosystem, man-made plus the original ecosystem. But to sustain is something that need to be considered, because it takes like a holistic commitment and effort from not only from the social, but also we need, like for example, budget from the government, and also not everyone have like same thought and also same what we call it, same thought and also same perception to sustain the ecosystem. So it's very subjective actually. But it's good to have like young people that really want that. For example, the Tasik Chini issue, young people that really want to sustain the Tasik Chini. But after all, as I said, ecosystem is dynamic. If you want that thing happen today, maybe in 10 or 20 years in future, there will be some other legislation, law or policy that might affect whatever that we have by now. Hopefully I satisfied you, Nurjana, yeah? Nurjana?
Nurhana, yes.
Nurhana, sorry. Nurhana, Nurjana.
It's a good that. Actually, our time is over, but we have a two raised hand. Is it okay for you, Dr. Faezah, to have two questions more, because there are two students already raised hand also to have to answer to have questions. Is Faezah, Salsabila, and Farah Sabrina.
Oh, that's my student.
I think this is from ITS.
Uh-huh.
Okay. Do you willing to continue?
No problem.
Okay, great. So maybe Faezah Salsabila first. You can unmute yourself and ask the questions. Thank you.
My name is Faezah Salsabila from Department Biology ITS. I want to ask, can the selective logging system in Malaysia support carbon stock and forest conservation in Malaysia?
Can the current selective management system,
Yeah,
support the
carbon stock, I think.
Forest conservation in Malaysia.
Oh, the current selective management system.
Yeah.
Okay, support the conservation. So far, that is the recent practice that we have in Malaysia, selective management system. So until today, I think that is the practical implementation that we have in Malaysia to sustain like the cutting cycle, but not all. Even though we have that cutting cycle for every 25 to 30 years, to 30 years, for example, but there are also some loop as my in data, as I said just now, where they cannot they cannot revisit the area to monitor the regeneration process. But still, what we have today, like in Malaysia, I can consider that we still can sustain the forest ecosystem, because we are talking about forest ecosystem as selective management system. So we still can have, we can sustain the forest ecosystem that we have. But I believe that everyone heard that illegal logging, even though we have like so thick documentation on policy and law, but still some of the states is against the law, and also they will against like doing that thing. So those are the limitation to achieve that conservation vision to forest ecosystem.
Great. Is that answer your question, right, Faezah?
Yeah.
Okay, thank you. I think Faezah is so shy today. So the second is for Farah Sabrina. Maybe you can unmute yourself.
Okay, Bu, thank you for the opportunity. My name is Farah from Department Biology ITS. My question is, in Malaysia, is there any case about production forest that being used as a tourism place? And if there is a case like that, how does the regulation work to keep the ecosystem safe? Thank you.
Productive tourism?
Sorry, I repeat. Is there any case about production forest that being used as a tourism place? And if there is a case like that, how does the regulation work to keep the ecosystem safe?
Production forest that is abused for...
That is used for tourism place.
Yes. Tourism.
Yes. Maybe is there any case in Malaysia that production forest is also like a tourism?
Yes, I don't have like a big data on the production forest that is used for tourism purposes, but I strongly believe that the production forest that we have, it is meant for the economic purposes, because we have lots of protection forests under wildlife park, Taman Negara, for example, habitat conservation for the tourism. But that I'm not sure if there is like illegal tourism activity where they actually, where maybe the tourist company, they brought their customer to that kind of production forest. I'm not sure about that, but maybe there are activity happen in that production forest, that illegal logging or something. That is another story, because you are talking about that tourism thing, right? But I don't think that the production forest is being abused to the tourism activity in Malaysia, because we have the protection forest. I think people would like to go to the protection forest instead of looking at the production forest, because many more to enjoy.
Yes, yes, this is the same thing that we have also. Maybe the name of Taman Negara is also national park.
Yes,
Taman Nasional in Indonesia.
Taman
This is the
Nasional.
same thing, right? Okay, maybe is there any questions again? Or we already at the 10:06 right now. Already understand. Oh, okay. We have questions in the chat from the Afrina. Doctor, do you think our native forest can be commercially exploited without destroying its ecological value?
Okay, I think the exploitation maybe must be done in a sustainable way, or maybe we need to have like a systematic way, or we need to totally plan, okay, what is the best thing to do if we want to commercialize that native forest. For example, if we have like cocoa, I can't remember the name of the trees that produce perfume and oil. Cocoa, camphor, kapo. Ryobalanops, I think Ryobalanops aromatica, not Ryobalanops aromatica. Another one else, where it is actually one of the commercial, that species has its own commercial value, and that species also can be for native forest. But to commercialize that product from that tree species without destroying the ecological value, that's why we have, as I said just now, that's why we have that production forest, because usually all the exploitation happen at the production forest. So that is also the reason why big portion from the protected forest has been was allocated to the production forest. And as you can see, the protection forest is like maybe 20% from the total forest that we have in our country. So that is the only forest ecosystem that we still can, and perhaps we can sustain the ecological services or ecological value that we have. Okay.
Okay, understand. Thanks. Okay, there are any questions again? Once more, maybe, or I'll go in there. How? I think Indah already still unmute. It's okay. Maybe if there is no questions, because I think we already have a limit time, but I think our collaboration will continue for the future, right, Dr. Faezah? Because I saw that your remain of the I just saw your plan and also research you using RDA and the other, and for the habitat for the trees and the others. This is the same thing with the already we want to have a research also in that area with Indah also. Maybe this year we just start.
You are welcome to our forest site if travel is allowable after pandemic.
Oh, great.
So now
I would love to. I would willing to accompany you to go to my forest site, and I think I would love to come to your site also in Malaysia.
Actually, right. So we can feel the motivation and also the spirit of doing field work.
That's great. It's been a long year. We cannot go freely to do a forest sampling, right? Because very restricted for the pandemic, and also I think we cannot go very go to go out from the town and the other. I hope that next year the pandemic is over and we can go very freely. Maybe they're from Ibu Indah also have some remarks, or you want to talk something?
I think I don't have any question to Dr. Faezah because I already forced my student.
So all the questions is actually channeled to students.
Maybe I just hope, I just wish that our cooperation will be further, will be still continue. Because yesterday I talked to Dr. Faezah, we can still do joint research, for example, or we can go, for example, co-author, co-authorship in the journal or something like that. And also maybe the student, we can exchange the student. For example, the student able to get sample or sampling in the forest in Malaysia and
things in Indonesia
also,
also.
Okay, maybe I hope this cooperation will continue.
That will be great because we have some kind of mechanism in ITS. We call it laboratory internship. So maybe student from Dr. Faezah can apply this kind, and Ibu Indah Trismawati as a ecology laboratory head of ecology laboratory can assign the letter. So the student from Dr. Faezah can also do lab internship. So maybe this kind of lab internship program can convert to the I don't know, in Malaysia maybe you have a kind of subject to convert the laboratory. Yes, transfer. Yes, transfer credits.
Is that international office program from ITS?
We have a student exchange, we have a laboratory internship, and also we have a collaboration. For the collaboration, maybe we should have like arrangement, letter of arrangement between maybe Dr. Faezah and Ibu Indah, maybe between the laboratory, so we can provide good collaboration and with the research, or you can go like a staff mobility programs. Maybe not this year we can go to Malaysia with that, but maybe for the next year we can do with this kind of program if you are willing to do it.
The laboratory intensive is it must be done physically, right?
Yes, yes. For the previous one, we do it physically. So for this pandemic, we ITS didn't offer this kind of programs to this year. Yes, yes. Maybe for 1 month or 3 months better.
So we shall have good collaboration in future.
Yes, agreed. So there's not limited with the research collaboration, but also with a lot of kind of collaboration with our institute. Have a program in that one.
Yes,
that's great. Okay. Thank you so much for Dr. Faezah binti Pardi for such an excellent lecture today. We have a lot of motivation right now. I have a lot of motivation right now to going to the field.
Okay, of course, yeah.
I'm just willing to see the green scenery in front of my eyes every day.
Yeah,
it makes us more smarter, I think, when I see green. Okay. Thank you also for the participant and student from the UiTM and also from the ITS. And we have today Ibu Nurnali Saada, Bapak Aunur Rahim, Bapak Edwin, and also Ibu Dian Saptarini Thank you so much for you coming to our guest lecture today. And I hope that our guest lecture is not stopped in here. We can continue in the future. Maybe in the next semester, we also have the same thing, looks like this. And also the next collaboration between the lecturers and also the student can continue with the smooth and success. Once again, thank you so much for Ibu Dr. Faezah.
Bu Iska, maybe we can
Yes.
like a group photo.
Oh,
Okay,
take a
can
photo
we
together.
Okay, I'm forget it.
Oh,
Okay, great. Maybe we need to remove spotlight first.
We can
I think we need to remove the spotlight.
switch on the camera.
Yes, please turn on the camera for all. If you are willing to help me also to take a picture.
Yeah, I can see Hidayati here, Nur Ain Natasha, Nur Afika. Sri Izzati.
Oh, great. I can see a lot of beautiful faces today.
Please, student.
Oh, there are a lot of
listen on
girls
your
here.
video and make the beautiful pose together.
What kind of beautiful pose?
Beautiful pose?
I always meant to do this. Small love for you all. Or big love?
Big love. It's fun.
Oh, is it ready?
Yes.
Oh, it's ready?
Okay, Ibu Indah maybe also can help me take a picture. Or Bu Nurnailis.
Bu Nailis.
Sometimes Bu Nailis more better have a picture.
Yeah, Bu Nailis more better
take a picture.
Gadget, I think.
Maybe I can count Bu Nailis.
Bu Nailis still mute. I'm sorry, Bu Nailis still mute.
Okay, maybe you can count it, Bu Nailis.
I'm sorry, Bu Indah.
Ya.
Bisa dalam dihitungkan 1, 2, 3-nya kemudian difotokan.
Hey. 1, 2, 3.
The next page. Okay.
Next page. Okay, finish, Bu Indah.
Okay, thank you.
Thank you, Ibu Nailis.
Nailis.
Thank you so much.
Thank you all, and I think this is the end of our lecture today. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi.
Assalamualaikum warahmatullahi wabarakatuh. Thank you, Dr. Faezah.
Thank you.
Bye. Thank you.
Goodbye.
UiTS and UiTM.
Thank you.
Yes, thank you. Makasih Bu Dian.
Oh, Bu Dian masih ada.
Ibu Iska.
Terima kasih Bu. Terima kasih semuanya.